Space is never truly empty. We often think of it as a great nothingness, a black canvas where stars are just tiny points of white paint. But that is a mistake. The space between the stars is heavy. It is filled with dust, with cold gas, and with silence. It is a silence so deep and so old that it feels like a physical weight pressing against the hull of any ship or the glass of any telescope. In this vast darkness, there is no sound, there is no wind to blow through your hair. There is only the endless freezing night and the slow, steady movement of time. Usually, time in the universe moves very slowly. It is measured in millions and billions of years. Stars are born, they burn for an eternity, and then they die. Galaxies collide in a dance that takes longer than the entire history of the human race. Compared to this cosmic clock, a human life is less than a blink of an eye. But today the cosmic clock has changed its rhythm. It is no longer ticking in eras or eons. For the people of Earth, the clock has suddenly started to race. The timeline has shrunk. It is no longer about millions of years. It is about 48 hours. 2 days, that is all that remains. To understand why this is happening, you must look past the moon and past the familiar planets like Mars or Jupiter. You must look into the deep velvet darkness where the sun is just a bright star, not a warm companion. Out there moving with a terrifying purpose is a visitor. We call it 3i Atlas. The name sounds technical, like a code in a computer, but the reality is far more simple and far more frightening. It is a rock, but calling it a rock is like calling the ocean a cup of water. 3i Atlas is an object from outside our solar system. It was not born here. It was born around a different star perhaps before the dinosaurs walked on Earth. It was thrown out of its own home by gravity cast into the lonely dark, and it has been travelling in silence for eons. It has drifted through the empty spaces between stars, invisible and cold until now. The size of Atlas is difficult to truly imagine. The scientists say it has a mass of 33 billion tons. 33 billion. Try to visualize that number. Imagine every building in a massive city, all the steel and concretes. Now imagine a mountain made of iron. 3i Atlas is a dense, dark shape roughly 5 kilometers long. It is not a round ball like a planet. It is jagged and uneven like a shard of broken glass or a bone gnawed by a giant animal. Its surface is darker than coal. It reflects almost no light. This is why we did not see it coming until it was almost too late. It cloaked itself in the darkness of space, hiding in the shadow, a ninja moving in the night. Now, however, it is no longer hiding. It is here. And it is beautiful in a terrible way. If you could float next to it, you would see the scars on its surface craters from collisions that happened millions of years ago in a galaxy far away. You would feel the cold radiating from it, a temperature near absolute zero. It is a ghost from the deep past arriving to haunt the present. But the most frightening thing about Atlas is not its size or its darkness. It is its speed. In our daily lives, we think 60 miles per hour is fast. An airplane flies at 500 miles per hour. But in the cosmic scale, 3i Atlas is moving at speeds that defy common understanding. It is cutting through the solar system at dozens of kilometers every single second. It moves faster than a bullet. It moves so fast that if it were to travel from London to New York, it would arrive before you could finish reading this sentence. This speed brings us back to the concept of time. Distance in space is usually our safety. We look at a star and we say that is 10 light years away. It means the light took 10 years to reach us. We are looking at the past. When we look at the stars, we are seeing ghosts of what used to be. This distance keeps us safe. Exploding stars and black holes are dangerous, but they are far away, locked in the distant past. 3i Atlas has broken this rule. It has closed the distance. It is not in the past, it is aggressively in the present. The gap between us and it is closing with every beat of your heart. The safety of distance has evaporated. The atmosphere in the tracking stations on Earth is strange. You might expect screaming or chaos, but there is none. Instead, there is a stillness that mirrors the silence of space. Men and women in white shirts stare at computer screens. The rooms are cool and hum with the sound of fans cooling the massive servers. They are watching numbers scroll down the screen. Coordinates, velocity, angle of approach. Everything is math. The universe is speaking the language of mathematics, and the message is clear. The numbers do not lie, they do not hope and they do not bargain, and they simply state the facts. The trajectory, the path the object is taking is locked. Gravity, the invisible hand that guides the movement of planets, has grabbed hold of 3i Atlas. The sun is pulling it in, Earth is in the way. This waiting period, these final 48 hours, feels unnatural. The sky outside looks the same as it always has. The sun rises in the east and sets in the west. People are drinking coffee, walking their dogs and driving to work. but above them, beyond the blue sky, the executioner is approaching. There is a profound contrast between the noise of humanity and the silence of the rock. Down here, we have politics, arguments, love songs, and crying babies. Up there is only the kinetic energy of 33 billion tons of matter moving at impossible speeds. The rock does not care about our history, it does not care about our art or our wars. It is blind and deaf. It follows only the laws of physics. This is the cosmic clock. It is the realization that our human time, our schedules, our deadlines, our weekends is an illusion. Real time is the movement of celestial bodies. Real time is gravity, and right now the cosmic clock is counting down the final seconds of an era. As the hours tick by, 3-eye Atlas gets brighter for the telescopes. It is no longer just a shadow, it is a physical object occupying our space. It is getting large enough to block out the stars behind it as it moves. It is like a thumb pressing down on a picture, erasing the background. The scientists calculate the impact force. They do not use words like big explosion, they talk in terms of energy equivalents to billions of nuclear bombs. But even that comparison fails. A nuclear bomb is a weapon made by humans. This impact is the hammer of the gods. It is the kind of event that ends geological ages. It is the kind of event that turns a lush green planet into a barren wasteland. So the world waits. We are trapped in the hallway of time, waiting for the door to open. We are suspended between the normality of yesterday and the catastrophe of tomorrow. The beauty of the stars has turned into a cage. We look up, and for the first time in history, we do not see wonder. We see a deadline. The silence of space is no longer peaceful. It is the intake of breath before a scream. The countdown has begun. 48 hours, the clock is ticking. To understand the true mystery of the interstellar visitor, we must look past its strange elongated shape and look inside its heart. We must talk about weight. When astronomers first looked at the data returning from our telescopes, they found a number that simply did not make sense. Based on how the object was moving, how it held its course, and how it interacted with the invisible gravity of our sun, the mathematical models suggested a mass that was impossible for a natural rock of that size. The figure was staggering 33 billion tons. To put that massive number into a human perspective, imagine digging up a giant mountain, compressing all that rock and dirt down into a tight ball and throwing it into the sky. But even that comparison fails to capture the reality. A normal asteroid, the kind we have seen drifting in the asteroid belt for centuries, is essentially a floating pile of rubble. It is loose rocks, dust pebbles, and pockets of empty space held together by very weak gravity. If you were to reach out with a giant hand and squeeze a normal asteroid, it would crumble like a dry cookie. It is light. It has a low density. It is porous like a sponge made of stone. However, this object was fundamentally different. For it to be the size we measured, yet weigh 33 billion tons, it could not be made of loose stone or porous ice. It had to be something else entirely. The math screamed that this object had a density similar to solid metal. It was 10 times, perhaps 20 times denser than the typical space rocks we have studied for 100 years. It was not a floating gravel pile, it was a solid slab. It was a monolithic block of iron, or perhaps something even heavier, something synthetically compressed by an unknown manufacturing process. This immense weight leads us to the most unsettling part of the physics, the concept of inertia. To understand why this is so strange, we have to visualize inertia. Imagine a vast dark ocean at night, completely still. In this ocean you have two vessels. One is a small toy boat made of folded paper. The other is a gigantic solid steel battleship, heavy and deep in the water. If you take a deep breath and blow air from your lungs onto the paper boat, it will skitter away across the water instantly. It is light. It has low inertia. It is easy to push. But if you blow that same breath against the steel hull of the battleship, it will not move. It sits there heavy and student. The force you applied is swallowed by the sheer mass of the ship. The ship ignores you. This is exactly what we saw happening in the darkness of our solar system. Usually when a visitor from the cold outer reaches enters our neighborhood, the heat of the sun wakes it up. This is the standard behavior of a comet. The ice on the surface boils instantly into gas. This gas shoots out in jets. According to the laws of physics, specifically Isaac Newton's third law, for every action there is an equal and opposite reaction. When the gas shoots one way, the rock is pushed the other way. This is a natural rocket engine. In scientific terms, we call this non-gravitational acceleration. It simply means the object is moving because of something other than gravity, in this case the push of its own gas. We saw signs that the object was outgassing. We detected the behavior of a surface reacting to the sun. Logic and history dictate that the object should have accelerated. It should have been pushed off its course significantly. The paper boat should have moved when the wind blew, but it didn't, or at least it did not move nearly enough to match the physics of a natural object. This is the paradox that keeps physicists awake at night. The object was spewing gas, yet its trajectory remained stubbornly steady. It lacked the expected violent push that a comet would experience. Why? The only explanation brings us back to the 33 billion tons. The rocket engine of the gas was firing, but the ship was too heavy to care. The force of the outgassing was hitting against a mass so dense and so solid that the push was negligible. It absorbed the energy and kept its line. It moved with the silent, terrifying confidence of a freight train ignoring a gentle breeze. This absence of the expected non-gravitational acceleration changes everything we know about the object's composition. If it were a natural comet, a ball of dirty ice, the outgassing would have sent it tumbling and speeding up wildly. The fact that it maintained such a rigid path implies that the structure is incredibly solid. It suggests a shell. If you have a thin shell made of heavy metal, and the inside is filled with complex machinery or tightly packed exotic matter, the overall density becomes astronomical. The object becomes an anchor sliding through the frictionless sea of space. Visually, this creates a haunting image. We are used to comets being lively, chaotic things. They spin, they crumble, they leave long, beautiful tails of dust that glow in the sunlight. They are messy, they are fragile. This visitor was clean, it was precise. It cut through the solar system without the chaotic wobble of a natural rock. It felt less like a piece of debris and more like a projectile. The physics of the situation creates a silence in the data. Usually nature is noisy. Data points jump around because natural objects are uneven and react unpredictably to heat. But here the line of movement was smooth. The weight of the shadows it cast was immense. It suggests that what passed by Earth was not a random visitor, but a vessel built to withstand the harshness of interstellar travel. A natural rock glides because it falls. This object glided because it had momentum that nothing in our solar system could easily disturb. It was a bullet of ultra-dense matter. When we look at the absence of that extra push, the non-gravitational acceleration that went missing, we are really looking at a display of power. It takes a lot of energy to move 33 billion tons. The sun tried to push it with heat, the gas tried to push it with pressure, but the object ignored them. It followed its own path, governed only by the initial force that sent it here millions of years ago. It behaved exactly like that giant steel ship, powered down, drifting silently through the night, too heavy for the waves to rock it, too dense for the wind to turn it. It was just passing through, and our physics were merely suggestions that it chose to ignore. The results from the mass spectrometer are not just surprising, they are scientifically unsettling. When the readout flickered onto the screen, it showed a composition that defies the fundamental laws of cosmic probability. The material is nickel, pure, unadulterated nickel. The alarming part is not what is there, but what is missing. There is absolutely no iron. To understand why this absence sends a shiver down the spine of a physicist, we must look upwards far beyond the atmosphere into the burning hearts of the cosmos. We must look at the alchemy of stars, because in the natural world, nickel and iron are not just neighbours on the periodic table. They are cosmic twins born from the same catastrophic death. The stellar furnace. Every atom in your body, the oxygen in your lungs and the metal in your car was once forged inside a star. A star is essentially a massive gravity engine, a sphere of gas so heavy that it crushes its own core, creating immense heat and pressure. This pressure forces atoms to smash into each other and fuse a process we call stellar nucleosynthesis. For most of a star's life, it burns hydrogen. It smashes two hydrogen atoms together to create helium, releasing energy in the process. This energy fights back against gravity, keeping the star inflated and shining. But eventually the hydrogen runs out. The star contracts, gets hotter, and starts burning helium to make carbon and oxygen. Think of an aging star like a giant onion. As it gets older and hotter, it creates layers. The outer layers burn lighter elements, while the core gets heavier and heavier, burning neon, magnesium, and silicon. With every step, the star has to work harder. It has to get hotter to squeeze these heavier nuclei together. The iron dead end. Then the star hits a wall, it hits the element iron. In the nuclear world, iron is unique. It is the most stable element in the universe. Fusing elements lighter than iron releases energy like a fire giving off heat. However, if you try to fuse iron into something heavier, it consumes energy like trying to light a wet log. When a massive star begins to manufacture iron in its core, the engine stops. The fire goes out. Without the outward pressure of fusion to hold it up, gravity wins instantly. The core collapses in a fraction of a second, followed by a rebound explosion of unimaginable violence, a supernova, the cosmic shotgun. This is where the relationship between nickel and iron becomes permanent. In the extreme heat of that final explosion and the moments leading up to it, the star produces vast amounts of the iron peak elements. These are elements with atomic numbers near iron-26, specifically cobalt-27 and nickel-28. Nature produces them in a chaotic radioactive soup. Specifically, the star often produces a radioactive version of nickel-56. This unstable nickel decays quickly in a matter of days into cobalt-56, which then decays into stable iron-56. Because of this decay chain and because they are formed in the same region of the dying star, iron and nickel are blasted out into the universe together. They travel through the void as a mixed cloud of dust and gas. When gravity pulls this dust back together to form new solar systems, asteroids and planets, the metals remain mixed. This is why meteorites, rocks that fall from the sky are almost always iron-nickel alloys. If you pick up a metallic meteorite, it is usually about 90% iron and 10% nickel. They are chemically inseparable in the chaos of space. Nature is a messy cook. She throws everything into the pot and stirs it together. She does not sort her ingredients. The impossibility of purity. This brings us back to the artifact in our hands. If this object were a natural formation, a shard of an asteroid or a piece of a dead planet core, it should be saturated with iron. The atoms of nickel should be locked in a crystalline lattice with atoms of iron reflecting their shared birth in a supernova. But the spectrometer shows 0 iron. To achieve this level of purity, the material must have been subjected to a process that does not exist in nature. Separating nickel from iron is incredibly difficult. They have similar melting points, they have similar densities, they react to magnets in similar ways. In our modern history, we only learned to separate them efficiently in the late 19th century, using complex chemical engineering such as the Mainde process, which uses carbon monoxide to bond with nickel and pull it away from the iron, turning it into a gas before solidifying it again. It is a dangerous, toxic, and highly technical process. The signature of engineering, the existence of this artifact, tells a story that is no longer about astronomy. It is about engineering. The absence of iron is the signature of intent. It implies that someone or something took the raw chaotic ore provided by the universe and imposed order upon it. They mined the asteroid or the planet crust, they crushed the rock, and they used advanced metallurgy to isolate the nickel atom by atom. This suggests a metallurgical civilization. A society that didn't just use stones or raw metals found on the ground, but one that understood the fundamental chemistry of the elements. They viewed the chaos of the supernova not as a final product, but as a resource to be refined. The artifact is not just a piece of metal, it is a triumph of order over entropy. Nature strives for equilibrium and mixture. This object strives for purity. It stands in total opposition to the natural history of the galaxy. It is a manufactured silence in a room full of cosmic noise. Holding this piece of pure nickel is like finding a perfectly cut diamond gear inside a rough coal mine. It suggests that long before we learned to light our own fires, there were others who had already mastered the furnace. They didn't just watch the stars, they mimicked the intense conditions of a star's core, but with a precision that nature itself cannot achieve to forge a metal so pure it feels alien to the very earth it rests upon. When we look at the sky, we usually see chaos disguised as order. We see asteroids tumbling through the dark and comets falling inward, like stones dropped into a well. They are wild ancient things driven only by the blind laws of gravity. But when the astronomers and mathematicians finally mapped the full trajectory of 3I Atlas, they did not see the wild stumbling of a rock. They saw the clean, sharp lines of a blueprint. They saw a path that was so precise it felt less like nature and more like a decision. To understand why this object frightened the scientific community, we first have to look at the ecliptic plane. Picture our solar system not as a ball, but as a flat dinner plate. The Sun is in the centre, and Earth, Mars, Jupiter, and the other planets all spin around it on this flat surface. This is the neighbourhood where all the traffic happens. Usually when an interstellar object, a visitor from outside our star system, arrives, it comes from the deep spherical shell of space known as the Oort cloud. These random visitors almost always drop in from above or below the plate. They dive down at steep angles, loop around the Sun, and fly back out into the dark. It is a messy three-dimensional plunge. 3I Atlas did not do that. It approached us from the side. It slid into our solar system almost perfectly flat, moving parallel to the ecliptic plane. It did not crash through the ceiling, it entered through the front door. Statistically, the chances of a random rock from deep space perfectly aligning with the flat plane of our planets are incredibly low. It suggests that the object did not just fall here by accident. It suggests that the object knew where the road was and decided to drive on it. But the angle of approach was only the first anomaly. The second and perhaps more chilling detail was its interaction with the red planet. As 3I Atlas cut through the silence of space, it passed Mars at a distance of roughly 2.7 million kilometers. In our daily lives, millions of kilometers sound like a vast, unbridgeable ocean. But in the language of the cosmos, where distances are measured in light years and billions of kilometers, 2.7 million is nothing. It is a hair's breadth. It is a whisper. To put this in perspective, think of the solar system as a giant football stadium. If the sun is a marble in the center and Mars is a grain of sand circling in the stands, 3I Atlas passed within inches of that grain of sand. This brings us to the mathematics of probability. If you were to close your eyes, spin around in circles and fire an arrow into a stormy sky, what are the odds that your arrow would hit a specific mosquito flying 5 kilometers away? The odds are effectively zero. It is technically possible, yes, but no rational person would bet on it. The universe is almost entirely made of empty space. The gaps between planets are terrifyingly huge. For a random object to travel trillions of kilometers from a different star system, drift through the void for thousands of years, and then just happen to thread the needle and pass right by. Mars defies the logic of chance. Astronomers call this a gravitational keyhole. It is a specific window in space that a spacecraft aims for to use a planet's gravity to swing itself toward a new target. When we launch our own probes like Voyager or Cassini, we spend years calculating these paths. We use supercomputers to ensure we hit that keyhole perfectly. 3I Atlas hit a similar keyhole without any computers that we could see and without any engines that we could hear. This leads to a profound contemplation on the nature of the universe, this difference between randomness and design. Randomness is messy. It is a pile of leaves blown by the wind. Design is intentional. It is a straight line drawn on a map. When we look at the trajectory of 3I Atlas, we are forced to ask, is this the beauty of celestial mechanics, or is it the work of a navigator? There is a cold, terrifying beauty to it. Celestial mechanics is the study of how things move under the influence of gravity. It is the clockwork of the universe. Usually this clockwork is passive. A moon orbits a planet because it has no choice. It is trapped in a gravity well. But 3I Atlas moved with a hypervelocity, a speed so high that the sun's gravity could not trap it. It was not a prisoner of our system, it was a tourist. The image that began to form in the minds of the observers was not of a tumbling asteroid, it was the image of a survey ship. Imagine a vessel sent out by an advanced civilization. Its mission is not to conquer but to map, to catalogue, to see what is out there. It enters the solar system flat to get the best view of the planets. It performs a close flyby of Mars, perhaps to scan its surface to check for water or to analyse its atmosphere. Mars is often considered a stepping stone for life, a planet that once held oceans. If you were an alien architect surveying our system, Mars would be a priority target. You would want to take a close look. The precision of the path implies that the flyby was necessary. If the object were just a rock, it wouldn't care about Mars. But if it is a machine that distance of 2.7 million kilometers might be the exact range needed for its sensors to capture high-resolution data. This changes how we view the object emotionally. If it is a rock, it is just nature throwing stones. But if it is a survey ship, then the path is a story. It is a story of curiosity. It implies that someone or something wanted to know about us. Or perhaps more humbling, they didn't care about us specifically, they just cared about the real estate. We often think of ourselves as the center of the universe. We assume that if aliens came here, they would land on the White House lawn. But a surveyor, a true architect of the stars, might not care about our politics or our borders. They might look at the solar system the way a geologist looks at a mountain range. They are looking for resources, for stability, for energy. The trajectory of 3I Atlas was a straight line through our history. It treated the gravity of Jupiter and the Sun not as obstacles, but as tools to maintain its speed. It moved with the elegance of a figure skater and the ruthlessness of a bullet. When we calculate the odds, the alignment with the ecliptic plane combined with the precise Martian flyby, the coincidence explanation begins to crumble. It feels less like a lottery win and more like a sniper's shot. As the object continued its journey leaving Mars behind and diving toward the inner solar system where Earth waited, the question was no longer, what is it? The question became, what did it see when it looked at Mars, and what will it see when it looks at us? The architect's path was not drawn by chance, it was drawn by intent, and we were standing right in the middle of the road. Travelling at 137,000 miles per hour, is an experience that defies human intuition. On Earth, speed is something you feel. You feel the vibration of the engine, the resistance of the air, and the G-forces pressing you into your seat. But out here in the deep vacuum of the solar system, speed is stallent. It is a ghostly, frictionless glide. There is no air to scream against the hull, no bumps in the road, and no sound. If you were a passenger looking out a window, you would not even know you were moving. The distant stars would appear frozen, fixed in place like a painted backdrop. Only the sun, growing rapidly larger and more terrifying with every passing second, would give away the secret of this insane velocity. However, for the artificial intelligence governing this vessel, this speed is not just a number. It is a complex equation of survival. The object is falling toward the heart of the solar system, diving into the gravity well of the sun. At this speed, the environment changes from a cold, empty void to a raging storm of invisible forces. This brings us to the most baffling anomaly observed during the approach to the direction of the gas. To understand why the behavior of this object is so shocking to observers, we first need to look at how a standard comet behaves. A normal comet is essentially a dirty snowball, a mix of rock dust and frozen gases like water and carbon dioxide. As a comet gets closer to the sun, the heat causes these ices to turn directly into gas, a process called sublimation. This gas shoots out of the comet, carrying dust with it to form a tail. Crucially, the laws of physics dictate where this tail should go. The sun emits a constant stream of charged particles known as the solar wind, along with intense pressure from sunlight itself. This pressure pushes against the dust and gas released by the comet. Therefore, a comet's tail always points away from the sun. It acts like a windsock at an airport. No matter which way the comet is travelling, the wind blows the tail outward away from the star. If a comet is moving away from the sun, it actually flies tail first. But this object, this visitor, is breaking that fundamental rule. Sensors indicate a faint spectral luminosity, a glow, but it is not trailing behind the object. Instead, the glow is pointing forward. The gas ejection is occurring in the direction of travel. In the context of celestial mechanics, this is akin to seeing smoke come out of the front of a plane rather than the back. It suggests that the gas is not simply melting off due to heat, it is being expelled with purpose. If this were a natural rock, this forward glow would be impossible to explain without complex tumbling or uneven heating that usually tears comets apart. However, viewed through the lens of artificial design, the explanation becomes chillingly logical. If you expel gas in the direction you're moving, you are creating thrust in the opposite direction. This is not a tail, it is a brake. The hypothesis arises that the object is utilizing a retro-rocket maneuver. By shooting a jet of gas forward against the flow of the solar wind, the object creates a cushion. This could serve two distinct purposes. First, it could be a method of deceleration, a way to trim velocity to ensure the object enters a specific orbit, rather than being flung back out into the darkness immediately. Second, and perhaps more intriguingly, this forward-facing plume could act as a plasma shield. The solar wind is not a gentle breeze, it is a torrent of protons and electrons are moving at 1,000,000 miles per hour. For a high-tech piece of machinery, this radiation is dangerous. It can fry circuits and corrupt data. By ejecting gas forward, the object creates a bow shock, a bubble of density that deflects the harshest particles of the solar wind around the hull, much like a boat pushes water aside. The glow observers see is the friction of this artificial atmosphere colliding with the sun's emissions. From the perspective of the onboard intelligence, this is a moment of extreme precision. The AI is not merely floating, it is driving. Managing a vessel at 137,000 miles per hour requires reaction times measured in nanoseconds. The AI monitors the pressure of the sunlight which strikes the hull with the force of a physical hammer at this proximity. It senses the magnetic field lines of the sun which twist and snap like rubber bands. To the AI, the solar wind is a chaotic terrain. It constantly adjusts the angle of the vessel, tilting the cell or the hull to ride the pressure rather than be crushed by it. The ejection of gas forward is calculated to the gram. Too much gas and the vessel slows down, too much losing the momentum needed to escape the solar system later. Too little gas and the sensors might be blinded by radiation or the hull might overheat. There is a violent beauty in this struggle. The object is effectively swimming upstream. While every natural rock and dust grain in the system surrenders to the flow of the solar wind, this vessel fights it. The forward glow is the visible sign of that struggle, the friction of an artificial will imposing itself on natural forces. Imagine the calculations occurring inside that dark metallic shell. The AI must balance thermal management, rotating the ship so no single side melts under the glare, while simultaneously firing these forward thrusters. It uses the sun's own gravity as a slingshot, but it refuses to be a passive stone. It corrects its course, it stabilizes its rotation. This is the definitive proof that separates a rock from a machine, the ability to change one's fate. A rock falls where gravity dictates. This object, with its forward-facing exhaust and its defiance of the solar wind, dictates its own path. It is charging into the fire shields up ISO open, braking just enough to scan the planets it passes, a silent traveller, mastering the storm of the star. In the vast, silent expanse of the Jezero crater, a robotic explorer named Perseverance has been trundling across the red dust for years. It is a lonely sentinel, a mechanical geologist sent by humanity to answer the oldest question we have ever asked. Are we alone? For a long time, the answer seemed to be a resounding silence. The red planet appeared to be nothing more than a desolate graveyard of rocks and wind. However, recent data beaming back to Earth has changed everything. The rover arrived at an ancient river valley, a place known to scientists as Chayava Falls. It was here, amidst the dry dust and the biting cold, that the rover found a rock that looked unlike anything else. This rock was arrowhead-shaped and veined with white calcium sulfate, a clear sign that water once ran through it. But the most shocking detail was not the shape, but the markings on the surface. They were small irregular splotches, pale in the centre and ringed with a sharp black outline. Scientists immediately recognized the pattern. They looked exactly like leopard spots. On Earth, these spots are not just random geological accidents. They are specific chemical signatures. They appear when microbes living in rock use iron for energy, stripping the red colour away and leaving a white patch behind. The black ring is usually made of iron, and phosphate, a waste product of this microscopic feast. For the first time, humanity was looking at a potential fossil of ancient life etched into the skin of another world. To understand the magnitude of this, we must look back into the deep history of Mars. Today, Mars is a frozen desert stripped of its atmosphere and bathed in radiation. But 3 or 4 billion years ago, it was a mirror image of Earth. It had thick clouds, rain and roaring rivers. The Narration Vallis, where the rover currently explores, was once a rushing channel of water carrying mud and minerals into a giant lake. In those warm, wet waters, chemistry was beginning to wake up. Simple single-celled organisms may have clung to the rocks, feeding on the chemical energy provided by the planet itself. They lived, they replicated, and they died, leaving their chemical ghosts behind in the form of these leopard spots. The discovery of the Chayava Falls rock suggests that life is not a miracle unique to Earth, but perhaps a standard consequence of planetary evolution. If water and the right chemicals are present, life finds a way to begin. However, the tragedy of Mars is that while life began, it did not last. The planet's magnetic field collapsed, the solar wind stripped away the air, and the water evaporated into space. The microbes froze and suffocated, leaving only these silent markers in the stone. This brings us to the unsettling synchronization of current events. It is a strange cosmic coincidence that at the exact moment humanity uncovers the first persuasive evidence of extraterrestrial life on our neighbouring planet, the object known as 3i Atlas has arrived in our solar system. For decades we have scanned the stars, finding nothing. Now we look down at the red dirt of Mars and find a potential answer, while simultaneously looking up to see an anomalous visitor entering our home. The timing feels too precise to be accidental. In the vastness of geological time spanning billions of years, the window in which humans are capable of identifying these microscopic fossils is incredibly old, a mere blink of an eye. That 3i Atlas would perform its gravity assist maneuver around the Sun at this specific century, in this specific decade, raises a chilling hypothesis. Perhaps 3i Atlas is not just a traveller. Perhaps it is an observer. Consider the possibility that the emergence of life generates a signal, not a radio signal which we have only been broadcasting for 100 years, but a biological signal. Over billions of years, a biosphere changes the chemistry of a planet. It alters the atmosphere, leaving traces of methane and oxygen. It changes the surface composition. Maybe advanced civilizations launch automated probes like Atlas to patrol the galaxy, looking for these telltale signs of biological activity. Mars was once active. It triggered the sensors of the galaxy long ago, but then it went silent. Now Earth is loud. We are biologically rich and technically noisy, but we are also digging up the past of our neighbour. 3i Atlas acts as a mirror. It reflects our own curiosity back at us. We sent Perseverance to Mars to act as a detective. Is it possible that someone or something sent Atlas here for the exact same reason? The object's trajectory took it deep into the solar system, allowing it a clear view of both the thriving blue marble of Earth and the dead red wasteland of Mars. If Atlas is a probe, it is witnessing a tale of two planets. On one side it sees the leopard spots of Cheover Falls, the gravestone of a failed biosphere, a civilization of microbes that never got the chance to grow complex. On the other side it sees Earth, a planet where the microbes survived, evolved, grew legs, learned to build rockets, and are now reaching out to touch the dead remains of their neighbour. This creates a profound tension. We used to think we were searching for life in a void. Now we realise the void might be checking on us. The finding at Cheover Falls validates the idea that biology is common. If biology is common, then the evolution of intelligence might also be a standard step. If intelligence is standard, then the arrival of a probe like Atlas is not a statistical anomaly, but an expected event. We have triggered a threshold. We have become a species capable of recognizing the life that came before us. The leopard spots are no longer just stains on a rock, they are a message that the universe is capable of life. And 3I Atlas moving silently through the dark is the confirmation that the universe is also capable of watching. As the rover drills into the rock to collect the sample, hoping to bring it back to Earth one day, we must wonder if Atlas is recording this event. Is it logging the moment the children of Earth finally met the ghosts of Mars? The red planet serves as a warning of how fragile life is. It lost its chance. Atlas is here to see if we will lose ours or if we are finally ready to join the community of the stars. The mirror of Mars shows us our past potential. The presence of Atlas questions our future survival. The year 2025 did not arrive quietly. It crashed into history with the force of a tidal wave. For decades, humanity had been climbing the mountain of technological progress, taking slow, steady steps. But in 2025, it felt as though we had suddenly started to sprint. It was no longer about better smartphones or faster internet. It was about a fundamental shift in how we understood reality itself. On the surface, the world looked familiar, but inside the laboratories and data centers, a revolution was happening. Three distinct giants of technology, quantum computing, artificial intelligence, and nuclear energy were waking up at the exact same moment. Shutterstock. First, there was the breakthrough in the financial and data sectors. Major global institutions like HSBC began to publicly demonstrate the practical power of quantum computers. For years, quantum had been a buzzword, a magical concept that seemed far away, but now they were using it for real. These were not normal computers that thought in simple ones and zeros. These machines could think in multiple states at once, solving problems in seconds that would have taken a traditional supercomputer thousands of years. They were simulating complex markets and optimizing global logistics, but the implications went far deeper. By cracking these codes, humanity was essentially learning the language of the universe. We were building a brain capable of processing information at a scale that nature itself uses. Simultaneously, the realm of artificial intelligence took a massive leap forward with the release of models like GPT-5. This was not just a chatbot that could write poems or answer trivia questions. This was a synthetic intelligence that possessed reasoning capabilities. It could look at scattered data and find patterns that no human could see. It began to display a form of intuition. In the context of the approaching cosmic event, this was crucial. If a message were to come from the stars, it would likely not be in English or Chinese. It would be in the universal language of mathematics and patterns. Humans might miss the subtle signals, but an AI of this caliber would not. It was becoming the universal translator we didn't know we needed. Getty Images. Then there was the fire. For half a century, scientists had chased the dream of nuclear fusion, the ability to create energy the same way the sun does, by smashing atoms together, rather than splitting them apart. In late 2024 and early 2025, the barriers broke. We achieved net energy gain consistently. This meant we could finally create a mini-star on Earth that produced more power than it consumed. This was the final piece of the puzzle. Quantum computers and massive AI systems require immense amounts of electricity, more than wind or solar could reliably provide. Fusion offered the promise of infinite clean energy to power the very machines that would decode our future. This simultaneous explosion of technology was not a coincidence. It was a convergence. It was as if the distinct threads of human ingenuity were suddenly being woven together into a single strong rope. The quantum computers provided the processing power, the AI provided the intelligence, and fusion provided the fuel. This leads us to a profound reflection on the evolution of our species. When we look back at history, technological jumps often happen right before we need them most. We discovered antibiotics just before the global population boom. We developed the internet just as the world needed to become a global economy. Now we must ask the difficult question, are we preparing for this meeting without even knowing it? It feels as though humanity has been frantically building a receiver. For thousands of years we looked up at the night sky and saw only lights. We were deaf to the cosmos. If a civilization had tried to contact us in the year 1900 or even 90, we would have had no way to hear them, no way to process the data, and no energy source powerful enough to send a reply. We were a primitive tribe on a dark island, but in 25 the lights on the island turned on. There is an invisible connection between our internal leaps in technology and the external events of the universe. It is a strange synchronicity. Just as the signal from the unknown approaches Earth, an event that changes everything, we suddenly finish building the tools required to understand it. Is this merely luck? Or is there a subconscious drive in the human species? Perhaps we sensed on some deep biological level that something was coming. We rushed to build the artificial intelligence, not just to write our emails, but because we needed a mind faster than our own to negotiate with what comes from the sky. We rushed to master the atom, not just to light our cities, but because we needed the power of a star to stand on equal footing with a stellar visitor. The convergence of 225 suggests that we are not passive observers in this story. We are active participants. The universe does not speak to those who cannot listen. It waits until the child learns to speak before it starts the conversation. As the quantum processors hummed in the basements of banks like HSBC, and as the fusion reactors glowed with the heat of a trapped sun, the human race stood up straighter. We were no longer just looking at the stars with wonder. We were looking at them with readiness. The tools were in our hands, the mind was awake, the energy was flowing. We had unknowingly built a welcome mat made of silicon and plasma. The timing suggests that the arrival of the signal and the maturation of our technology are linked dancing to a rhythm we are only just beginning to hear. We were getting ready for the most important phone call in history, and just as we picked up the receiver, the phone began to ring. The most terrifying sound in the world was not the alarm, it was the silence that came after it. For weeks, the internet had been loud. Every social media platform, every news channel, and every blog was screaming about the anomaly. There were theories about aliens, about black holes, about the end of days. But then, on a Tuesday morning that felt ordinary in every other way, the noise simply stopped. It did not fade away slowly. It was cut off like a power cord pulled from a wall socket. This was the beginning of the silent strategy. It started with the space agencies. For decades, the relationship between the American agency NASA and the Chinese agency, the CNSA, had been cold. They were competitors racing to plant flags and claim glory. They did not share data, they did not share radio frequencies. But suddenly, the invisible wall between them evaporated. Observers who tracked satellite movements noticed something strange. A heavy-lift rocket from Florida launched at the exact same time as a Long March rocket from the Gobi Desert. This was not a coincidence. To launch two massive objects into the same orbital plane requires a level of coordination that takes months, perhaps years of planning. They were moving with a synchronized precision that was mathematically perfect. They were no longer racing against each other. They were racing together against something else. The European Space Agency soon joined this silent dance. Telescopes in Chile and the Canary Islands, usually booked for years in advance by universities, were suddenly taken offline for emergency maintenance. Every major eye that humanity had on the sky was pointed at the same coordinate, yet no public announcement was made. The official schedules listed routine weather monitoring or communication upgrades, but the trajectory data told a different story. They were looking at the darkness. Then came the information control. This was the masterpiece of the modern age. The governments did not ban the topic of the anomaly. Banning something makes people curious. Instead, they used a technique called flooding. Overnight, the news feeds were filled with noise. A celebrity scandal involving a famous actor took over the front pages. A minor political disagreement in a small country was blown up into a major crisis. Cat videos, cooking trends, and viral dances were pushed to the top of every algorithm. If you searched for the anomaly, you would find old articles or debunked theories. The fresh data, the real photos, and the leaked reports were buried under mountains of digital junk. It was a soft censorship. It was not a wall, it was a fog. You could try to walk through it, but you would lose your direction almost immediately. The comment sections on websites, usually full of arguments, became strangely empty of specific keywords. If you typed the coordinates of the object, your comment would simply fail to post due to a server error. This control extended to the scientific community. Astronomers who had been vocal about the approaching object suddenly went on vacation. Their university emails sent back automatic replies. Some received grants for massive amounts of money to study completely different topics effective immediately. The message was clear without ever being spoken: look away and you will be rewarded. Look closer and you will disappear from the conversation. But you cannot hide the sky from the people who love it. This is where the psychology of the crowd began to shift. Humans have an instinct for danger, a primitive sense that evolved to help us survive predators in the tall grass. That instinct began to tingle. Across the world, amateur astronomers, the hobbyists with telescopes in their backyards, felt the change. They saw the subtle shifts in the light. They noticed that the stars in a specific sector were being blocked by something moving at 30,000 kilometers per hour. When they tried to share their findings on forums, their accounts were flagged for spreading misinformation or violating community standards. This created a deep, unsettling paranoia. It was the feeling of a secret being kept in a crowded room. You know everyone is thinking about it, but no one is brave enough to say the words. The public began to feel a disconnect between what they saw with their own eyes and what the screen told them was real. The weather was normal, the sports games continued, the stock market ticked up and down by 1 or 2%. But underneath the normality, there was a vibration of fear. It was the uncanny valley of reality. Everything looked perfect, but it felt wrong. The most profound change, however, happened in the shadow world of geopolitics. The old maps of alliances and enemies became useless overnight. For 50 years, nations had pointed nuclear weapons at each other. They argued over borders, over trade tariffs, and over ideology. But the anomaly rendered these arguments small and petty. It was like two children fighting over a toy, suddenly realizing there is a tiger in the room. The toy no longer matters. Survival is the only currency that counts. Intelligence reports that were once classified top secret and locked in secure vaults in Washington were now being couriered by hand to Beijing and Moscow. Military frequencies that were encrypted to keep enemies out were now open to allow secure lines of communication between generals who just a month ago were planning war games against each other. They were moving resources. Massive amounts of steel fuel and rare electronic components were vanishing from the open market. Prices for raw materials spiked by 300%, but the news anchors blamed supply chain issues or labour strikes. The truth was that the world's superpowers were building something. They were building it fast and they were building it together. This cooperation was not born out of friendship, it was born out of terror. The leaders of the world had looked at the mathematics and the result was a cold equation. If they stood alone, the probability of survival was 0%. If they stood together, it arose to perhaps 5%. They chose the 5%. The silence was necessary because panic is inefficient. If the public knew the truth that an object larger than a mountain was on a collision course, or that an alien signal had been decoded, society would collapse. Trucks would stop delivering food, power plants would be abandoned, money would become worthless. To build the defense or the escape ships, the governments needed the world to keep turning. They needed the factory worker to go to his job, the truck driver to deliver the fuel, and the engineer to design the circuit. So they lied. They lied by saying nothing. The atmosphere felt heavy like the air before a summer thunderstorm. People walked through the streets looking up a little more often than usual. They held their children a little tighter. They stopped arguing about politics at the dinner table. There was a collective unspoken agreement to enjoy the quiet even if it was false. In the control rooms of NASA and the ESA, the mood was somber. There were no cheers, no high fives. The scientists worked in 12-hour shifts, their eyes red from lack of sleep. They watched the screens where the object was tracked. It was getting closer. Every day it covered millions of kilometers. The silent strategy was working. The world was calm, but it was the calm of a person holding their breath. Eventually, the amateur astronomers found a way to talk. They used old ham radios, Morse code, and encrypted peer-to-peer networks. They whispered the truth to each other across oceans. They shared the coordinates. They confirmed the speed. They realized that the silence from the governments was not because they didn't know what to do. It was because they had already decided who would be saved and who would be left behind. The silence wasn't empty. It was full of preparation. The ships were not being built for everyone. The coordination between the superpowers was not to save the human race, but to save a specific fraction of it. The supply chain issues were actually the hoarding of supplies for deep underground bunkers and orbital arcs. As the object passed the orbit of Mars, the silence became deafening. The truth was no longer a whisper, it was a vibration in the floorboards of the world. The strategy had bought them time, but time was running out. The veil was about to lift, and when it did, the noise would return louder than anything humanity had ever heard before. To understand our place in the universe, we must first be willing to grade ourselves honestly. Professor Avi Loeb, the former chair of the astronomy department at Harvard University, has never been afraid to give humanity a report card, and the results are humbling. When we look at our technological maturity and our behaviour on a cosmic scale, Loeb suggests we are currently scoring about a 6 out of 10. This is not a grade of excellence. It is a grade of mediocrity. In his view, humanity is arguably a Class D civilization. This means we are not yet capable of recreating our astrophysical conditions, and worse, we are actively destroying the only home we have. If the universe is a school, we are the unruly students in the back of the class setting fire to our desks while ignoring the vast library of knowledge surrounding us. Professor Loeb gained global fame and infamy for suggesting that the interstellar object named Oumuamua, which passed through our solar system in 2017, might not be a rock. Its shape was strange, appearing flat or cigar-like, and it accelerated in a way that gravity alone could not explain. While most scientists rushed to classify it as a comet or an asteroid, Loeb asked a simple, dangerous question: what if it is artificial? This brings us to a major barrier in our search for extraterrestrial intelligence: the deep conservatism of academic science. In the modern world, we like to think of science as a purely objective pursuit of truth. We imagine scientists as emotionless observers who follow the data wherever it leads. However, the reality is that science is a human enterprise driven by humans who have careers, reputations, and mortgages. In the current academic system, stepping outside the safe boundaries of accepted knowledge is risky. If a young astronomer devotes their time to searching for alien technology, they risk being ridiculed. They might lose their funding or be denied tenure. It is much safer to study rocks, dust, and gas clouds than to study the possibility of starships. This creates a self-fulfilling prophecy. We do not find evidence of alien technology because we are too afraid to look for it, and because we do not look, we say there is no evidence. This resistance to new ideas is not new. It is a fundamental part of the history of science, best explained by the philosopher Thomas Kuhn. In his famous framework, Kuhn described how science progresses. Most of the time, scientists are engaged in what he called normal science. This is like solving a puzzle where everyone agrees on the rules and what the final picture should look like. Scientists work to fit the pieces together, refining measurements and adding small details to the existing picture. However, sometimes a piece of the puzzle does not fit. These are called anomalies, like the strange movement of Oumuamua. At first, the scientific community ignores the anomaly, or tries to force it into the old picture. They might say the equipment was broken or the calculation was wrong, but eventually, if enough anomalies pile up, the old picture breaks. This leads to what Kuhn called a paradigm shift. A paradigm shift is a violent revolution in thinking. It is when we realize the puzzle we were solving was the wrong one entirely. This happened when Galileo showed that the Earth was not the center of the universe. It happened when Einstein showed that time is not constant. Today we are likely standing on the edge of a new paradigm shift regarding life in the universe. The old paradigm says life is rare, humanity is special, and we are likely alone. This is the comfortable normal science view. It makes us feel unique. It makes us the main characters of the cosmic story. Professor Loeb and others are pushing for the shift. They are arguing that the universe is likely teeming with biological and technological debris, and we have simply been too blind or too arrogant to see it. They argue that the extraordinary evidence we require is already here, but we are filtering it out because it does not fit our worldview. Why is this shift so difficult? It comes down to two profound conflicting human fears: the fear of being alone and the fear of not being alone. First, consider the fear of loneliness. If we are truly the only intelligent life in a universe that spans billions of light years, it is a terrifying thought. It means the universe is a vast empty house, and we are the only conscious candle burning in the dark. It places a terrible burden of responsibility on us. If we destroy ourselves, the universe goes silent. This thought makes us feel incredibly small and isolated. But the second fear is perhaps even stronger, the fear of not being alone. If we accept that the universe is full of advanced civilizations, perhaps civilizations that are millions of years older than us, we lose our steer. We are no longer the pinnacle of creation or the special children of God. We become average. We become like ants, living in a forest unaware of the highway being built right next to our hill. If there is a civilization that scores a 9 out of 10, or a 10 out of 10 on Loeb's scale, we are at their mercy. This triggers our primal instinct for survival. Throughout human history, when two civilizations meet, the one with less advanced technology usually suffers. We project our own violent history onto the stars. We assume that if aliens are powerful, they must be dangerous. Therefore, the academic conservatism is not just about data. It is a psychological defense mechanism. By denying the possibility of alien technology, we keep our world safe and predictable. We keep ourselves at the top of the pyramid. Professor Loeb suggests we need to grow up. He argues for cosmic humility. We need to accept that we are likely not the smartest beings in the neighborhood. The scientific method requires us to be modest. It demands that we look through the telescope with open eyes, ready to accept whatever we find, even if it hurts our ego. A 6 out of 10 civilization acts with arrogance, assuming it knows everything. A mature civilization understands that it knows very little. The scale of understanding is not just about measuring the distance to the stars, it is about measuring the distance between our current ignorance and the truth. To cross that distance, we must be willing to be wrong. We must be willing to let go of the idea that we are the center of everything. As we continue to scan the skies for radio waves or laser flashes, we are not just looking for data, we are looking for a mirror. Finding others will force us to finally see ourselves clearly, not as the masters of the universe, but as a young, fragile species, just beginning to learn how to walk. The space around the red planet is usually a place of quiet routine. For years, the robotic residents of Mars have kept their heads down. They are geologists and cartographers trained to stare endlessly at the rusty dust, the deep canyons and the polar ice caps. They look for ancient water. They map safe landing sites for future astronauts. They are creatures of habit, circling in predictable loops, their antennas humming with the slow, steady work of planetary science. But as 3i Atlas raced inward from the dark outer edges of the solar system, that routine was shattered. A command went out from Earth. It travelled at the speed of light, taking nearly 14 minutes to bridge the vast gap between our blue world and the red one. When the signal arrived, it triggered a wake-up call unlike any in the history of spaceflight. The command was synchronized across 3 continents on Earth, sent by agencies that usually competed for prestige, but were now united by a singular urgent curiosity. The message to the machines was simple: stop looking down, look up. The first to react was the Mars Reconnaissance Orbiter, known to its operators as MRO. Built by NASA, this spacecraft is the veteran of the Martian fleet. It is a large aging bird, having flown in the harsh radiation environment for nearly 2 decades. Its joints are stiff, its batteries are degrading, and its reaction wheels, the spinning gyroscopes that help it aim, have been showing signs of wear for years. MRO carries a camera called HiRISE. It is the most powerful camera ever sent to another planet, essentially a massive telescope flying in space. Usually it can spot a rock the size of a dinner table from 300 kilometers up. But HiRISE was designed to take pictures of a stationary ground, not a bullet speeding through the cosmos. To catch a glimpse of 3i Atlas, the engineers at the Jet Propulsion Laboratory had to perform a maneuver that terrified them. They had to tilt the entire spacecraft. MRO is not a turret. To aim the camera, you must turn the whole ship. It was like trying to turn a heavy bus while driving on ice. Thrusters fired in short, sharp bursts, expelling precious gas. The spacecraft groaned under the thermal stress as sunlight hit sensitive parts that usually stayed in the shadow. It was a dangerous gamble. If the turn was too fast, the spacecraft could lose its lock on Earth, leaving it tumbling and silent. But the ship obeyed. It twisted away from the Martian surface, pointing its heavy glass eye toward the black void. Thousands of kilometers away, another machine woke from its slumber. This was Tianwen-1, the pride of the Chinese space program. Compared to the American veteran, Tianwen-1 was young, agile, and equipped with modern sensors. It was currently in an elliptical orbit, swinging high and low over the Martian poles. The team in Beijing sent a frantic series of code updates. They needed to change the orbit of Tianwen-1 completely. They did not just need to turn the camera, they needed to physically move the ship into the path of the intruder. The main engines ignited, burning for minutes that felt like hours. This was a phasing maneuver. It was a matter of pure mathematics and timing. They were trying to arrange a meeting between a robot moving at 3 kilometers per second and a comet moving at nearly 40 kilometers per second. If they missed the timing by even a minute, the two objects would pass each other in the dark, separated by too much empty space to see anything. Finally, there was the Mars Express, the European Space Agency's enduring survivor. It was the oldest of the 3, a machine that had lived far past its warranty. It had survived glitches, memory failures, and near-death experiences. It was running on backup systems of backup systems. Yet it had a unique talent. It carried a powerful radar system and a wide-angle camera that could capture the context of the scene. The controllers in Darmstadt, Germany knew their ship was fragile. Asking Mars Express to track 3i Atlas was like asking a grandfather to run a sprint. But they did it anyway. They sacrificed their fuel reserves burning propellant that was meant to keep the probe alive for another 5 years. They spent the future to buy a few minutes of the present. This was the grand coordination. It was a silent ballet of metal and silicon performed in the vacuum. There is a profound fragility to this dance. On Earth, we are used to technology feeling solid. Cars are heavy, buildings are made of concrete. But in space, these machines are incredibly delicate. They are wrapped in gold foil thinner than a sheet of paper. Their skeletons are made of lightweight aluminum and honeycomb carbon. They are sensitive, shivering things exposed to the harshest elements of existence. Cosmic rays, solar flares, and the absolute zero of the shadows. And they were trying to capture an image of something that represented the opposite of fragility. 3i Atlas was a mountain of brute force. It was a solid chunk of ice and rock heavier than a city carrying the momentum of 1,000,000 years of travel. It did not care about the delicate sensors trying to study it. It ploughed through the magnetic fields of Mars, creating a shockwave in the solar wind that buffeted the tiny spacecraft. The timing had to be perfect. Because of the distance, the humans on Earth could not use a joystick to control the cameras. There was no live feed. By the time the images reached Earth, the event would already be over. The controllers had to program the sequence days in advance, predicting exactly where Atlas would be. It was a shot in the dark. As 3i Atlas crossed the orbital plane of Mars, the 3 ships began their work. It happened in total silence. There was no sound of shutters clicking, no whirring of motors that you would hear in a movie. MRO stabilized its jitter. Its massive lens opened. It began snapping images in a rapid strip, slicing the darkness into long, thin pictures. It was looking for surface details, cracks, craters venting gas. Tianwen-1 used its medium-resolution camera to look for the coma, the cloud of dust and gas surrounding the object. It was trying to taste the atmosphere of the visitor to see what it was made of. Was it water? Ammonia? Something we had never seen before. Mars Express fired its radar pulses. Invisible waves of energy bounced off the dark surface of the intruder and returned to the ship. These echoes would tell us about the density of the object. Was it a solid rock or a loose pile of rubble held together by weak gravity? For 20 critical minutes, the 3 machines were the only witnesses in the universe. They were the eyes of Earth. This is the most poetic realization of the encounter. Down on the surface of our planet, billions of people were going about their day eating, sleeping, working, fighting. But up there in the cold silence of the Martian system, humanity was awake. We had extended our nervous system across the solar system. We had taken silicon and copper and glass, and we had taught it how to see. As the intruder sped away, disappearing back into the twilight towards the sun, the spacecraft slowly powered down their high-stress modes. They turned their antennas back toward Earth to begin the long, slow process of uploading the data. The grand coordination was over. The machines were tired, their fuel tanks were lighter, and their reaction wheels spun a little rougher than before. But stored in their digital memory banks were the first close-up portraits of a visitor from the stars. The eyes of Earth had blinked open at the right moment, and soon we would see what they saw. For decades we have pointed our radio telescopes at the sky, listening to the cosmic static. We search for patterns in the noise. We look for a message in a bottle floating in the vast ocean of space. But have you ever stopped to ask, are we truly ready to open the bottle? This is the threshold of contact. It is the moment right before everything changes. While the search for extraterrestrial intelligence, SETI often focuses on technology, antennas, frequencies, and data processing. The real challenge is human. The discovery of a signal from another civilization would not just be a scientific breakthrough. It would be a mirror that reflects our own nature back to us. The ripple effect on society. If a verified signal arrives tomorrow, the news will travel at the speed of light, digitally speaking. It will not stay in a laboratory. It will flood our phones, our televisions, and our dinner table conversations. This event, often called first contact, would send shockwaves through every pillar of our society, religion and faith. For thousands of years, humans have looked to the heavens for gods and meaning. Some fear that discovering aliens would destroy religious faith. However, history suggests otherwise. Most religions are very adaptable. Many theologians argue that if a creator made the universe, that creator likely made more than just one inhabited world. Instead of destroying faith, contact might expand it. It would move us from a village mindset, where we think we are the only important people, to a galactic mindset where we appreciate the vastness of creation. The economy and the military. The reaction of governments and markets is harder to predict. There is a concept in economics called information asymmetry. This means that whoever has information that others do not have possesses power. The economy stock markets hate uncertainty. The initial news might cause panic. However, over time, the possibility of new knowledge, new energy sources, or new materials taught to us by an advanced civilization could drive a massive economic boom. The military. This is the most dangerous aspect. If we receive a message containing technical instructions, who owns that message? Is it the country that received it? Is it all of humanity? There is a risk that nations might compete to decode the message first to gain a military advantage. This highlights why international cooperation is vital before a signal is found. The power of the people, citizen science. You might think that preparing for contact is a job for government officials or PhD scientists, but in the modern era the search belongs to everyone. This is the rise of citizen science. Because the universe is so big and the amount of data we collect is so massive, professional scientists cannot analyze it all by themselves. Programs like SETI at home changed the game. They allowed ordinary people to use their personal computers to help process radio data when they weren't working. This does more than just crunch numbers. It makes the search democratic. It reminds us that the sky belongs to everyone. When a school teacher in Vietnam or a student in Brazil donates their computer power to the search, they are saying, "I am part of this human journey." It prepares the population psychologically. We aren't just waiting to be told the truth, we are helping to find it. The psychological shift, what if we are not alone? This brings us to the most important question, the one that touches your personal life. What does it mean for you as an individual if we are not alone? The end of cosmic loneliness. Deep down, many humans feel a sense of isolation. We look at the cold, dark stars and feel small. We feel like orphans on a tiny rock. Confirmation of intelligence elsewhere would cure this cosmic loneliness. Knowing that someone else is out there, perhaps asking the same questions, looking at their own night sky, creates a sense of connection. It validates that life is not an accident. It means that consciousness, the ability to think and feel, is something the universe does, not just something that happened once by mistake. A new human identity. Psychologists often talk about in-groups and out-groups. We define ourselves by who we are not. I am from this country, not that one. I support this team, not that one. First contact would create the ultimate out-group, the extraterrestrials. But this has a beautiful side effect. It would force us to redefine our in-group. Suddenly, the differences between a person from Asia, Europe, or Africa seem very small. We stop seeing ourselves primarily as citizens of a nation and start seeing ourselves as Earthlings. It is similar to the overview effect reported by astronauts. When they see Earth from space, they don't see borders. They see one fragile blue marble. Contact would give all of us that feeling without leaving the ground. Humility. Before the universe. Finally preparing for contact teaches us profound humility. For a long time, humans believed the Earth was the center of the universe. Science corrected that. We learned we orbit the Sun, then we learned the Sun is just one of 400 billion stars in our galaxy. Then we learned our galaxy is one of billions in the observable universe. Finding another civilization is the final step in this lesson of humility. It means we are likely not the smartest, the oldest, or the most advanced beings. We are like children walking into a vast library filled with adults. This humility is not meant to make us feel bad, it is meant to make us feel precious. If life is rare, we must protect it. If life is common, we must learn from it. Conclusion. The internal preparation. The threshold of contact is not a line in space, it is a line in our minds. Whether or not we ever hear a signal, the act of searching changes us. It forces us to grow up. It asks us to be ready to listen not just to the stars, but to each other. It asks us to organize our own planet, to stop our petty conflicts, and to present a unified face to the cosmos. When we look up at the night sky, we are not just looking for aliens, we are looking for a better version of ourselves. The preparation for contact is ultimately the preparation to become a mature civilization, one that is worthy of joining the galactic community. We have arrived at the final threshold. It is here in these last 18 hours that the entire journey finds its meaning. Imagine the silence of the control room back on Earth. The cheering has stopped, the speeches are finished. Now there is only the quiet hum of computers and the rhythmic breathing of the scientists who have waited a lifetime for this moment. But far away, 3 billion miles from where you lie, resting, the silence is even deeper. It is the absolute velvet silence of the void. The spacecraft, our brave little mechanical explorer, is entering the most critical phase of its life. It is all happening now. Every calculation made over the last decade, every course correction, every drop of fuel used has led to this precise point in time and space. It is a convergence. Like threads of a great tapestry finally weaving together, the math, the physics, and the dreams of humanity are meeting at a single coordinate in the dark. For the next 18 hours, the spacecraft must work alone. It is too far away for us to guide it in real time. It takes hours for a radio signal to travel from Earth to the ship, and hours more for the answer to return. We cannot steer it. We cannot help it. We have taught it everything it needs to know, and now we must let it fly free. There is a profound beauty in this trust. It is like releasing a bird into the open sky, watching it soar into the unknown, trusting that it knows the way. Imagine the spacecraft turning its body. To focus its cameras on the mysterious world ahead, it must turn its antenna away from Earth. This means the connection is broken. The line is cut. For this final crucial day, we are met with silence. We do not know if the systems are working. We do not know if the engines are stable. We only know that it is out there floating in the dark, doing exactly what it was built to do. It is a solitary dancer in the vast theatre of the cosmos. While we wait, let your mind drift to what is happening out there. The cameras are opening. They are capturing light that has travelled from the sun, faded and weak, reflecting off the icy surface of a world we have never truly seen. These are not just pictures, they are time capsules. The spacecraft is collecting data at a feverish pace, filling its memory banks with the secrets of the solar system. It is measuring the temperature, which is hundreds of degrees below zero. It is tasting the thin atmosphere. It is mapping mountains made of ice and plains made of frozen nitrogen. We are waiting for the high-resolution images. We have dreamed of them for years. Up until now, this world was just a fuzzy dot of light, a pixelated mystery. But soon, when the data finally trickles back home across the ocean of space, that dot will become a place, a real place. We will see canyons deep enough to swallow empires. We will see craters that remember the violent history of the early universe. We will see the horizon of a world that has been lonely for 4 billion years. But that is for tomorrow. For now, there is only the waiting, and in this waiting there is peace. Let the anticipation melt away from your shoulders. Let the need to know the need to see simply fade. There is a lesson here in the final hour of the mission. It teaches us patience. The universe does not rush. It took billions of years to build that little icy world. It took billions of years to forge the atoms that make up the spacecraft and the atoms that make up you. The universe operates on a scale of time that is slow, deep, and rhythmic. Think about the signal that will eventually come home. It is travelling at the speed of light, 186,000 miles per second. Yet the distance is so vast that even light takes hours to cross it. That signal is a whisper moving through the dark. It passes the orbits of giant planets. It passes through the dusty rings of the solar system. It crosses the cold, empty stretches where nothing exists but dust and silence. It is a long, lonely journey home, carrying a message of discovery. As you lie here, you are part of that connection. You are the observer. The universe is experiencing itself through you. The cold emptiness of space is not scary. It is peaceful. It is a blanket of calm. The stars are steady lamps that have burned for eons, watching over the turning of the worlds. We have done all we can, Shuriyabu. The science is finished. The commands are sent. Now we surrender to the outcome. There is a great relief in surrender. We accept that there are things beyond our control. We accept that the universe is larger, stranger, and more beautiful than we can comprehend. Whether the images show us a dead rock or a dynamic world of geysers and glaciers, it is perfect. It is exactly as it is meant to be. The final hour is not an end. It is a transition. It is the moment night turns into dawn. It is the moment the unknown becomes the known. But even when we know the answers, the mystery remains. For every question we answer, the universe whispers 2 more. And that is okay. It means the story never ends. It means there is always more to dream about. So let the spacecraft fly. Let it sail past the target, carried by its own momentum, drifting further into the Kuiper belt, into the attic of the solar system. It will keep going long after we are asleep, long after we are gone. It is a monument to human curiosity, a silent ambassador sailing forever into the night. Close your eyes now. Visualize that vast starry darkness. It is not empty. It is full of potential. It is full of peace. You are safe here on this blue island, while the great machinery of the cosmos turns slowly overhead. The data is coming. The pictures are on their way. But for this moment, the mystery is enough. The waiting is enough. The silence is enough. Drift along with the ship. Float in the weightlessness. There is no up or down, no heavy or light. There is only the gentle drift. The stars are blurring into soft streaks of light. The questions are fading. The answers will be there when you wake up. For now, simply be. Be one with the vast, quiet, ancient dark. Rest in the knowledge that you are part of something magnificent. Good night, explorer. The universe is watching over you.